Well, thank you. Thank you for coming. Always appreciate it every year, your presence and good stories. So again, pleased to be here. And this year, we don't have a lot of big news, but we got some news to share with you. So, come in. Okay, so I guess last year we celebrated the 30 years of the entry into service of the PW 100 family. It's been a great success for us. And this year it's sort of a continuation of that 30 years, and it'll come in, culminating at the end of this year with the entry into service of the ATR family. So some key dates, of course, the entry into service of the first Q 100 was late last year in December. This year the Embraer, the Brasilia, which was the second product for which entered service, was in October, and you can see the ATR. The ATR entered service in '85 with Air Littoral. Interestingly enough, as soon we certified the 124A. I think 95 seems like a long date there. I think it's 85. And then 20 years ago, we continued, and that journey continued for a number of years. And 20 years ago, the 121 Alpha, and the 119, which powered one of the Dornier jet, was also certified. So it's a journey that still continues. Next slide, please. And today, we've got 38 models certified, and I'll talk about the N in the next few slides. That was certified last year, but totally this year, we're up to 160 million flight hours with the 100 family, including the 150, 8,000 engines, and you can see the number of countries and operators operating the engine across the world. Thanks. So last year, we've announced the 127N engine. It was certified in May, and that powers the ATR 72-600. And the first application are with Avianca in South America. The engine, the 127N, offers 4.5% more takeoff power than the M engine, which already offered 4.5% more than the 127F, which is the standard engine for the ATR family. The interesting thing about these three engine rating, they're all on the N engine, they're all selectable. So these you can sort of operate, if you don't need a lot of power, you can operate the engine as an F rating for the lower rating for the longer life. But if you need the power, you can select an M engine or an N, and you can actually select different mode of operation too. If operationally you need more power to take off over in hot and high or short distances. So we're working, and I think I shared that with some of you. We're actually working some additional new hot end improvements for the engine, which will probably happen at the end of next year, the end of 2016. And those hot end improvements should give us about 2% additional better fuel burn. It's a way of we're reducing the operating temperature of the engine by making the turbine section more efficient. So of course, with lower temperature comes lower fuel burn and better improvement to the engine. And actually, the engine today is doing very well in service, and it is offering good, excellent fuel burn. So the N model, when those product improvements happen, they will be introduced as a kit, with the engine, and all the new production engine will have the latest hardware. So that's the story on the N. Next slide, please.
That's next year.
That'll be the end of next year, yes. The 150C was announced last year at the Farnborough Air Show. That powers the MA700 aircraft. The 150C is a derivative of the PW150A that powers the Q400. And today we've delivered over 1,000 engines of the 150 family. The 150C basically has been designed. Some improvements have been designed specifically for the MA700 requirements. Amongst those is a new gearbox, because the MA700 will use a different propeller than the Q400. So basically, it needed a new gearbox. We're changing the power turbine. We're adding a third stage of power turbine to improve the fuel efficiency. And the fuel efficiency will be about the order of 4 to 5% improvement over the base PW150. And we're modifying the compressor slightly to open up to the airflow in the compressor to improve the 150. So that's, the engine is slated for certification in 2018. We're right now doing all the joint development phase with the XAC to define all the installation requirement and the control system requirement to have the integration of the propeller and the engine together. And we're proceeding with the design changes for these new modifications to the engine. Next slide. NGRT, I know a lot of you would like me to come out and with a big story and say we're launching the NGRT. We're not there yet. I think we consider very strongly the need in the marketplace for a 90-seat turboprop. All the market analysis, market studies that we do point to that need in the near future, and the airlines are also telling us that they want a 90-seat aircraft. Today we're continuing with our compressor demo program. The compressor is the key technology of the NGRT engine. It's a unique technology for the compressor system, and by the end of this year we'll have completed the phase 2, the complete phase 2, what we call the phase 2 demo, which we would have had complete testing of the compressor system. We're doing that at MTU with our partner in Germany, and that will be completed. And at that point, all the technologies that we need to launch the new engine is ready. So in the meantime, we continue to work with the aircraft manufacturers to define the requirement. We're working at refining exactly their need in terms of air bleed, and electrical power generation in order for us to design the engine to the exact specification and optimize the engine design for the next generation of aircraft. Just a bit of an update as well. I think it's not a secret, but Pratt, a few years ago, Hamilton Sundstrand had an APU business in San Diego. A few years back, it was a Hamilton Sundstrand company. A couple of years ago, it moved into the Pratt group. So Pratt took over the responsibility of the APU business. Now we're sort of going a step further, and we're moving all the commercial APU business to Pratt Canada. So as you can see, we're going to sort of shut down the Aero Power facility in San Diego, and basically splitting part of the APUs, the smaller APUs, which are more are going to go with the military business down in West Palm Beach, and all the commercial APUs, the responsibility is going to move with Pratt Canada. So I think it's worth mentioning because we have a lot of, we've got a very strong presence in the regional market, and it complements well what we're doing in terms of in the turboprop business. So, you know, Pratt Group in terms of the turboprop has been a strong player in the regional business. Pratt US with the Geared Turbofan is going to be a very strong player as well in the main propulsion of the next generation of engines. But we're also very, very present on the APU world. So today in production, the Q400 uses a Pratt APU. The E-Jets all have Pratt APUs. It's the APS 2300. The new E2 will have an increase and improved, stronger APU as the 2600. And that same APU is also going to be used on the Mitsubishi MRJ and the Comac ARJ21. So I think it's worth an update. It's not something that we've talked a lot about, but I think, you know, in this RA convention, I think it's worth mentioning. So go to the next slide. Of course, our APU business not only does the regional market. We have an APU. The 3200 is on the Airbus A320. The APS 5000 is an all-electric APU that powers the 787. And of course, both the 901 and 980 are two very large APUs, both built and designed by Pratt Canada. One powers the 747-8, and the APS, the 980, is on the Airbus A380. So these are fairly large APU, almost 2,000 shaft horsepower. If you see those APUs, you'll see they're huge engines, but it sort of shows the breadth of our presence in the APU business. Next slide. Okay.
So do you get all of them?
Yes, all these APUs.
Not just the small APUs.
No, all the APUs. Actually, if you go back one slide, the 901 and 980 are already Pratt & Whitney Canada designed and produced. So we produced the first one for the 747-400. That was our first play into the APU business at Pratt Canada. So those, we produced over 800 of those. When the 980, when the A380 was designed, they asked us to produce the PW 980. That's on the Airbus A380. And of course, all the other APUs were part of Hamilton Sunstrand sort of make, if you want. And those ones were repatriating. And the reason is obviously these are primarily gas turbine engines. We specialize in gas turbine for main propulsion. It makes sense to be able to leverage the technologies across the Pratt group, and Pratt Canada being the small engine center of excellence. That's where we decided to put those commercial APUs. So go to the next slide. And of course, there's a way, the reason that we can do that is that we have a very, very large support network, and that's part of the goal of integrating the businesses, is to be able to leverage the investment we've made in our customer first centers, both in Montreal but also in Singapore, and leverage the 100+ field rep network that we have within Pratt Canada, and then we're absorbing as well the field rep network that existed within the APU business. I think we've talked a lot about the what we call the FAST system, which is the flight acquisition, storage, and transmission units. We've got those now certificated for the Q400 and 300 and 200. These are devices that can sort of take aircraft and engine data, store it, and transmit it to the Pratt & Whitney server, partition the data the way the airlines want. Some of the engine data obviously is being taken by Pratt to be able to provide advice on how to maintain the engine, but there's a lot of aircraft data also that is available for the airlines, so they can do their flight operation quality assurance. So we've got those systems well established on the Q400 and 300 series. It's been recently certified on the ATR 4272 platform. We've got an FAA certificate. We're working on the EASA certificate, and you know, we are now starting to push the system and sell the system to the ATR the ATR family of customers. So again, a system that has a lot of interest in the regional market. It provides a very economical way and reliable way of moving data, and the old classic system where people had to go and get SIM cards off airplane and try to put it into a computer. So this is done after every flight automatically. It doesn't transmit in flight. There's not a lot of advantage of doing this for an hour flight. You don't get a lot of pre-learning, even though it would transmit 30 minutes within the flight. You know, when you land, the data is transmitted, and most of the action can take place at that time. So I guess before the question period, I'll pass the baton here to my friend Jim. Will continue to give you an update on the Pratt & Whitney U.S. site and the turbofan, and then we'll move on to the question period afterward.